Alright, today we're going to talk about inverse trig derivatives, and these, I'm sorry to say, the best way to keep track of these is just to memorize the identities, but I am going to show you how we derive the one for inverse sine. So, this is what we're finding, d dx of inverse sine of x. Alright, the way that you do this is really weird, so if you need to pause it and go back, feel free to do that. Okay, so the first thing we have to remember is that y equals the inverse sine of x. So what that means, what we talked about yesterday, is that you can switch the x and the y and it becomes regular sine. So x equals regular sine of y. So in this case, y is the angle and x is the ratio. Same thing here, x is the ratio, y is the angle. Alright, so because we have this inverse 2, I just wanted to mention that if you remember from yesterday, the domain is limited. So x is between negative pi over 2 and positive pi over 2. And that's going to be important later. So we will keep that in the back of our minds. Okay, so now the next thing, I've got this x equals sine y, so what I'm going to do is implicitly differentiate this thing. So derivative of x is 1, the derivative of sine is cosine y, and then the derivative of y, because I have to do the chain rule, is dy dx. Alright, and now I'm just going to solve it for dy dx. So we've got 1 over cosine y equals dy dx. Alright, so that part's not so bad, but it's the next part that gets kind of strange. Alright, so cosine y, if we remember back up to this domain, if we look at cosine of y on that domain, so I'm just going to draw my graph really quick. Remember, it starts at 1, and then it goes down, and then it goes back up. Same thing on the other side, down, and then back up. Alright, but the important part is negative pi over 2 to positive pi over 2. Cosine is positive in that whole domain, negative pi over 2 to pi over 2. So because it's positive, then we can do what I'm about to do. Alright, so the other thing that we have to remember is that if we have sine squared theta plus cosine squared theta, it equals 1. So going back to this, if I just want cosine by itself, I could take cosine squared theta equals 1 minus sine squared theta, and then I want to get rid of the squared because I want to just have a regular cosine. So let me scoot that up a little. So I want to take the square root of both sides. The problem is, when I take the square root, it could be positive or it could be negative. Except, because I'm looking at negative pi over 2 to pi over 2, I know that it's going to be positive, so I don't have to pay any attention to that negative. So cosine equals 1 minus cosine squared equals 1 minus sine squared theta. Alright, so back up here, I can replace that cosine of y with this square root. So we've got 1 over the square root of 1 minus sine squared y equals dy dx. That's not the derivative though, there's one last step that we have to take. So sine squared y, if I remember all the way back to the beginning of my problem, x equals sine y. So sine y equals x. So sine squared y equals x squared. So I can change this part, the sine squared, to x squared. So 1 over the square root of 1 minus x squared equals dy dx. And that, right there, is the derivative of inverse sine. So instead of making you sit through 6 of those derivations, they're all basically done the same way. You're just going to use different functions and different graphs. But instead of making you sit through all of that, I'm going to give you the rest of them. Because I don't expect you to be doing this on the AP exam. Really, the best way is just to memorize these. So here is that table. And I'm going to zoom in on this so we can see it even better. Definitely write these down, memorize them, get tattoos, whatever you need to do. You will have to use these on your fall semester exam too. So those are the first 3. If you need to pause it, if you need more time to write it down, pause it. They're really important. So that's the first three, and those are the second three. And again, feel free to pause it, but I'm not going to pause in the video for you to write them down. Okay, so the next thing that we're going to do is an example problem of how to use these things. Alright, so let's get a new sheet of paper that hasn't been written on. Okay, so the first example, say we have to find, this is our y, it's an inverse sine of 3x plus 5. So I need to find the derivative of that, so I'm going to do y prime equals, this is the chain rule because I've got a function on the outside and 3x plus 5 is on the inside. So I have to do the derivative of the outside with the inside staying totally the same. So the derivative of inverse sine is 1 over the square root of 1 minus x squared, except I'm not using x, I'm using 3x plus 5. So 3x plus 5 squared. Okay. And that's great, but I still have to take the derivative of 3x plus 5 because chain rule, I did the outside, now I have to do the inside. And so just like the chain rule was before, we're going to multiply that by the derivative of the inside, which is just 3. And that's the answer. So that's all you have to do. Just remember that you have to do the derivative of this part too. Don't leave off the 3. Okay, now another example I want to do is how to find the tangent line. Basically the same thing again, but just to have one more example. Okay, so our next example, I have the function y equals the inverse tangent of x squared, and I want to find the equation for the tangent line at x equals 1. So the first thing I have to do, well, there's two different things you can do. You can plug x in and figure out what y is. So actually, let's just go ahead and do that. Alright, so that's 1 squared. So I need to figure out y equals the inverse tangent of 1. And remember that's opposite over adjacent. So opposite and adjacent have to be the same. That only happens in a 45, 45, 90 triangle. So that means that this has to be pi over 4. So now I have my point, 1 pi over 4. Alright, so now I'm going to go ahead and find the slope of my tangent line. Alright, so my derivative of this original one up here, I know the derivative of tangent is 1 over 1 plus x squared. 1 over 1 plus, but this time I don't have an x here, I've got an x squared here, so I have to do it like this. X squared squared. Because it's whatever this is squared. So that, same thing. Alright, and I also have to take the derivative of the x squared because it's the chain rule. I gotta do the derivative of what's on the inside. So I have to multiply this by 2x because that's x squared. Alright, and now, just like normal, we have the equation for the derivative, so we just take the 1 and plug it in to get the slope of the tangent line. So we've got 1 over 1 plus 1 squared squared, or 1 to the 4th, or it doesn't matter because it's 1 raised to a power, times 2 times 1, so y prime is equal to 1 over 2 times 2, which is really just 1, and now we've got our point up here, our slope here, and so we just write the equation for the tangent line, which is y minus pi over 4 equals 1 times x minus 1, just like that. So the biggest thing from today, just to reiterate again, remember, just go ahead and memorize these definitions, these derivatives, because that will be the easiest way to do it. Alright, and that is it for today.